make fuel, because after all, at high temperature, you can put in just fuels that would go into a refinery, like water, and you can split water into hydrogen and oxygen. And at concentrated sunlight, you can get temperatures that will exceed 1500 degrees centigrade. And water just splits then, by the laws of thermodynamics, into hydrogen and oxygen. You don't need catalysts, it just happens. You could run oil refinery equivalent reactions this way. Both of these have been shown in pieces. There's a system, for instance, zinc metal, at high temperatures in steam of water will make hydrogen and zinc oxide. Zinc oxide at very high temperatures will release oxygen and make zinc. And so you have two steps, one of which makes hydrogen, the other of which makes oxygen, catalyzed by a zinc oxide closed material cycle. So the input is heat, focused from the sun, and steam, and the output is hydrogen and oxygen that you vent. And then you would use the hydrogen in lots of things, probably not in vehicles. You could triple the energy content of biofuels by upgrading it with hydrogen and have a liquid fuel. That's just known technology. You could upgrade crude oil, do a lot of things. You could run reverse water gas shift reactions. So if you make a fuel, we'll figure out a way to use it without having to necessarily pump it into cars. Right? This is an engineering problem now. This cavity has to stay hot. You have to have molten flows of zinc and zinc oxide. They have to be confined. You have to get the gases in. You have to get the products out. The whole system can't have any optical leaks, or it doesn't get light in, and it can't have any thermal leaks, or it doesn't stay hot. So the leading work in this area is done by, in my view, that should be a Steinfeld, not Steinfeld, Aldo Steinfeld, who's at the ETH in Switzerland. And Sandia is doing a lot of work on making synfuel this way from just using the solar heat with a Fischer-Tropsch process at high temperature. Same idea. So this is interesting work and should not be ignored, in my opinion. You can find leading references to more of these things, again, in our workshop report on solar thermal. Another option is to take that high temperature heat, and instead of running an engine, is to have no moving parts. And there are thermoelectric materials, in principle, that can convert heat into electrical current. In fact, they do that in practice, where the figure of merit, the so-called ZT product, needs to be 3 in order to have the thermoelectric